All right, here's our question. Now, I did my job and I searched it on Google. I looked in books also and tried to come up with an explanation for you guys of what standard deviation is. And I'm not being very successful at it because it's still very confusing. So I have a lot of examples that we'll talk about. But here, I'll go ahead and read this. It says, it says, standard deviation is a number. Okay, standard deviation is a number that tells us the mean of how far a set of data derives from the mean of the data. That is, I can't even understand that, and I wrote it. So if you write it down, you're a sucker, because you shouldn't write it down. You should watch and understand. Okay, so we use this number in many different parts of our lives. We actually use it for describing a climate for different areas. We also use it for sports. That's probably the biggest because stats and probability are in sports a lot. We also use it for investments. All these different types of things in our lives use standard deviation or some form of it. And there's more. I'm just throwing out a couple. Now, this was kind of cool graph. I found it on Wikipedia, and I liked it, so I put it up here because I think it demonstrates what standard deviation is really well. Now, I'm going to make up what these numbers mean. Okay, I'm not going to say exactly what those numbers mean because I didn't quite understand it when I was looking at the graph on the website. But we're going to pretend that this blue color and this red color represent different teams. So we got the red team and we have the blue team. And for the sake of conversation, we're going to say that they're basketball teams. Okay. And down here, these numbers right here represent the number of points that they get in a game. So, I mean, obviously this is hypothetical because getting 230 points in a game is pretty dang gnarly if you're a basketball team. But we're going to pretend that these are basketball teams. Okay, you guys with me? You guys with me? No? With me? Okay, so if you were to find the average of these numbers, they would actually have the same average. They both have an average of 100 points. Okay, and that's interesting because you see this red. It's way different than this blue, and what makes the blue or the red go up is how often they score those points. So, for the blue team, it's clear that they scored 60 points more than they scored 30 points. You see, because the 30 points don't go up as high. You guys see that? You guys understand that part? And if we compare the red and the blue, let's see, how many times did the blue score 100 points? Well, not as much as the red, because the red's like way up here. Does that make sense? So who scored 100 points more often? The red team, clearly. All right. Now, if you were put into a room with 5 of your friends and you guys had to make a bet on who's going to win, who would you vote for? And this is all you knew. They gave you this graph and they said, okay, you need to place a bet on who you think is going to win. Okay. Now, most of you guys have different reasons for picking, the team that you would pick. Some of you guys might say blue, hands down, because blue has scored 170 points, and the red team has never even passed 120. Like, they scored 120 points, like, maybe one time. All right, but the blue team has scored 200 points a couple times. But wouldn't there be, like, other questions that you'd want to know? Like, why? How come the blue team has scored 0 points before, and they've also scored 230 points? How come they have such a big, wide range of scores? Really? Wouldn't you want to know that? I mean, that'd be a good question to ask. Because what if this was the reason? What if the reason why they scored 0 points in this game, but over in this game they scored 190, was because in this game they had 3 of their best players, and over here they're all injured. So they didn't have their players anymore, so they're not scoring points. It's like all of their guys that do rebounds and get the ball back so they can score points. So they never score points without those 3 players. That'd be pretty sad. But, right, like that could be the reason. How come this team, the red team, is always consistently scoring this many points?
They have a bunch of mediocre players.
No, they're all mediocre? Or they're mediocrely good?
Yeah.
very similar. So it doesn't matter like how many get injured; they're still going to score around this many points. So that would be interesting to know. And so when it comes down to actually placing the bet, wouldn't you want to see who's actually playing in the game? Like, okay, for the blue team, are the guys who got 190 points going to be in the game? Right? Wouldn't you want to know that? No? Okay. But what if you couldn't ask those questions? What would be the safer bet? The red team, right? Because it doesn't matter who's injured, who's playing, because they score more points consistently. And so when we find the standard deviation of these two teams' scores, the red, well, for this graph, the red is 10, and the blue is 50. So if you have a smaller standard deviation score, are you consistent or are you not consistent? You're consistent. So the smaller the standard deviation, in this case the red has a smaller standard deviation, the smaller standard deviation, the more consistent the scores are. And that goes for everything. For interest rates, the smaller the standard deviation, the less the interest rate, fluctuates. It's really consistent. It's trustworthy. Does that make sense? It's so standard deviation tells you how consistent something is or how trustworthy something is. That's what standard deviation is. And so let's look at the nuts and bolts of standard deviation. Now I gave you guys a chart to fill out. I gave you this ugly looking dude right here. And some goes, oh, why do you do that? Don't worry about that. Just fill out the charts. And you guys fill out the charts, no problem. You guys understood it really quickly. But let's talk about this stuff for a second. Let's do A and B first. Mean, which most of you guys understand that because you've learned it before. You add up all the scores and then you divide it by the number of scores. And so in this case, what was our mean for the things that we did in class? The 6.4, and n represents how many scores there were. How many scores were there? 10. There's 10 scores. And now I want to write down all of the scores. Okay, I deviated from the topic. Okay, so I wrote down all of the scores, and we got a mean of 6.4 and a number, n of 10. Okay, so that stuff's not new to you guys, but the new stuff is about to happen. This column right here. Oh, why are we doing this? That is this right here. It's x sub I represents each of these scores right here, and then minus mu. Mu is your mean. So the difference between the score and the mean goes right here, and that's what you guys put right there. And that's what's happening right here inside the group. And then you square it. That's all the numbers that are over here. So all you did was you subtracted the mean from that, and then you squared it, and that's what you got. Now everything over here has been squared should be positive, because whenever you square a negative number, it becomes positive. So it doesn't matter which number you put first when you find this difference, because you're going to square the number anyways. You're all going to get the same number squared. Okay? And so that's what this is right here. Now, what about this sigma right here? This sigma is a Greek letter. We use it to represent sum notation, summation notation. What that means is we're going to add all of these together. We start at the first x. See this x of I? We start at the first x of 1, x of I. And then we keep going. The n up here is 10. We keep going until we finally get to the x of 10. And so you add them all together, and then you get this down here. So the sigma with the group is whatever number you put down here. What did you guys get down there? 26.4? Okay, I'm just putting that there so you guys can have that. Now that's just 26.4. 26.4. What am I writing? 26.4. Okay, and then we get to the variance. Now the variance part is this part right here. Now I wrote right here mean of the difference from the mean squared. So what's the mean of this? Well, that's just taking all these numbers, the sum of all these numbers, you add them all up, and then you divide it by n. Kind of like when we found the mean right here. You add up all these numbers and divide by n. Well, the variance is adding all the differences from the mean squared, and then dividing by n. What did you guys get when you did that? 2.64. And that's why there's this 1 over n right here, because when we multiply this number, that whatever we get right here, by 1 over n, you're really dividing it by n. And then finally, we get the standard deviation, which is the whole point of this thing. You take the variance, which is 2.64, and you square root it. And so when you square root it, what do you get? 1.62. Good. And when you guys start getting big old decimals, just round to the nearest third decimal.